70, I would like you to look at these graphs, these two, figure 1 and figure 2 on page 570. See, this is a function of two variables, right? X and Y, and this is the function. Three variables, three-dimensional space. And this is a maximum, a function that has a maximum, a relative max. This is also a function of two variables. And this one has a relative minimum, as you see. And this is our next step. We're going to determine relative max, relative min for functions of two variables. And this is 6.3. 6.3, max min for functions f(x, y), meaning only two variables. Good. So we're going to use d-test. What is the d-test? Step number 1. The d-test is what we have to use to find max min for functions of two variables. So first step, find f(x) and find fy for the function that we want to find the max min for. Then step number 2, solve the system f(x)0, fy)0. Let's suppose we get a solution. As an example, the solution is a, b. We may get more than one solution. It's just an example. Let's say we get a solution from here. Then in step 3, we will calculate d. But what is d? d is f(x)(x) evaluated at this point times f(y)(y) evaluated at this point minus f(x)(y) evaluated at this point and squared. In step 4, analyze. Analyze. What am I analyzing? If this number d is a positive number and f(x)(x) at a, b is negative, f has a max, a relative max at a, b. Next possibility, d is, positive, not yet, negative. If d is positive and f(x)(x) at a, b is also positive, f has a relative min at a, b. Okay. What else can happen? If d is less than 0, no max min. If d equals 0, test is not applicable. Okay? So, let's summarize before we look at problems. I am given a function of two variables. I'm asked, does this function have a max or a min or both? I have to use the d-test. It's pretty similar to what we did with function of one variable. We determine the critical numbers, but here's a critical point. So we have to find fx and fy. We have to set them equal to 0 and create a system. Find points that make fx0 and fy0. Then I calculate. Once I have the point, I calculate the d number. I evaluate the second partial derivative at AB, fxx at AB, times fyy at AB minus fxy at AB, but squared. Of course, I should have maybe mentioned here from the beginning, also find fxx, fxy, fyy. Okay? But only use fx and fy to create a system to find points or point. And then I calculate d. I get a number for d. This is a number because I'm evaluating these functions, these derivatives, partial derivatives. So I get 15. If I get 15 and this is negative, then AB is a relative max. If I get 15 and this is positive, then the function has a minimum. And if I get negative 15 or if I get 0, no max min or test not applicable. It looks difficult, it's very easy. You'll see in a moment. Okay, so let's go to page 576. Six, not 9. Okay, here it is. Find the relative max or min value. And of course, we have to plug it in to find it. So these are problems that we are not looking at. These are restricted conditions. Okay, so we're only looking at 1 through 14. So these are from constrained optimization. So we do not cover this. We only cover finding the relative max or relative min. So let's choose, or I will.
Can we do number 10?
Number 10. Very good. So let's start with number 10. Very good. A sip of water. Good. Number 10. And that'll 576. So we're given the function f of x comma y, and that is x squared plus y squared plus 8x minus 10y. Perfect. Thank you. Okay, so let's find fx. fx is 2x plus 8. Let's find fy. Fy is 2y minus 10. Let's also find fxx, which is 2. Let's also find fyy, which is 2. Let's also find fxy. fxy, which is 0, which is equal to fyx, because fy there is no x. Good. So now, after finding all partial derivatives, I will create the system only with fx and fy. 2x plus 8 equals 0, and 2y minus 10 equals 0. From here, I know that negative 8 over 2, x is negative 4, and y equals 5. Negative 8 divided by 2, and positive 10 divided by 2. So the ordered pair in our general example a comma b for this function is negative 4 comma 5. Now we have to calculate d. D will be fxx evaluated at this point, but it's just 2. Fyy evaluated at this point, but it's just 2. Minus fxy evaluated at this point, but it's 0. And squared, so this is 4. So this is a positive number. And I'm looking at fxx. 2 is also positive. So fxx is a positive number. Therefore, negative 4 comma 5 is a relative min according to the d-test. What is the value? I don't know. I have to plug these numbers in here. So what is the relative minimum? It's r of negative 4 comma 5. So negative 4 squared, 16, plus 5 squared, 25, plus 8 times negative 4, negative 32, and 10 times minus 10 times 5, minus 50. So 31 minus, what is this, 82 equals negative 51. So according to the d-test, this function has a relative minimum at negative 4 comma 5. What is the value of the relative minimum? Negative 51. Any questions? I also want to show you on page 573, just for 1 second, to see what happens when d is less than 0. So see, this is like a saddle on a horse. So when d is less than 0, there is no max or min, you can already say it's a saddle point. When d is 0, the test is inconclusive. But when d is negative, so when d is positive, we have a max or a min. When d is negative, however, it's a saddle point. It's exactly like a saddle on a horse. Here it appears in this direction appears to be a maximum, and in this direction appears to be a minimum. So this is neither a max nor a min when d is less than 0. Good. So we're going back to page 9. Okay. Good. I hope you find this very, very easy. Before we look at the word, oh, what did I do? So let's select another problem, and then we'll look at a word problem. Okay, I'm going to choose 5. fxy is x cubed plus y cubed minus 3xy. Okay. Good, the same question. Find max min. So we have to find fx. So in this case, fx will be 3x squared minus 3y. We have to find fy, 3y squared minus 3x. fxx, 6x. fyy, 6y. fxy, negative 3. fyx, I'm checking, negative 3. Of course, correct. Now, this is what I need. So 3x squared minus 3y equals 0, and 3y squared minus 3x equals 0. From here I get point or points. We'll see in a moment. Of course, I'll divide both equations by 3. I have x squared minus y equals 0, and I have y squared minus x equals 0. I have to use substitution. So I'm going to solve this equation for y and plug it in here. x to the fourth minus x equals 0. I would factor out x, and I get x cubed minus 1. And this equation has 4 solutions, but 2 are imaginary. One solution is 0, and the other solution is 1 plus 2 imaginary solutions. How do I know? Okay, very simple. With the calculator, we go to apps, 9, the degree is 4. We enter the coefficients 1, 0 for x squared, for x cubed, 0 for x squared, negative 1 for x, and 0 for the free term. And here are 2 imaginary solutions. Here they are with I. And one solution is 1 and the other solution is 0. Good. And now I have to find the y. So if x is 0, y is 0. So one point is 0, comma 0. When x is 1, y is 1. And the other point is 1, comma 1. So I will have to determine the d test for both points. I'm going to start with 0, 0 first. So d for 0, 0. I have fxx 0, fyy 0, minus negative 3 squared, which is 9. So this number is less than 0, which means that this is a saddle point. Now I perform the operations for 1, 1. I have to find d for 1, 1. So fxx 6, fyy 6, minus a negative 3, which is squared, which is 9. 36 minus 9, I don't even care for the number, it's a positive number. And fxx is positive. When both are positive, 1, 1 is a relative minimum. What is the value of the function at 1, 1? I have no idea. And that would be the value of the minimum. I have no idea. 1 plus 1 minus 3, negative 2. Any questions? Any questions? Anyone? Any questions? Pretty straightforward, I think. Let's continue with the word problem. Maximizing profit, since we hit 2 minima. So let's look at maximizing now. A concert promoter produces 2 kinds of souvenir shirt. Total revenue from the sale of X thousand shirts at $18 each and Y thousand of 25 each is given by. So we have, that's 19, and we have the revenue as 18X plus 25Y. And the company determines that the total cost in thousands of dollars is 4x squared minus 6xy plus 3y squared plus 20x plus 19y and minus 12. How many should be produced? How many shares should be produced to sold to maximize profit? So again, revenue Okay. It didn't say, but I'm assuming that everything is in thousands of dollars. Okay. So first of all, we have to create the profit function. Oh, let me